Now let's take a look at how excessive heat can cause degradation or damage to the soldering iron tip. Lead-free soldering processes may require higher soldering temperatures, which means that the tip plating will be exposed to higher surface temperatures. Bringing the hot tip into contact with a cleaning sponge that is too wet can result in an extreme temperature shock that can produce micro cracks in the iron plating layer. Keeping the tip clean is important, but constantly wiping it with a damp sponge can cause early tip failure. Excessive wiping causes the tip temperature to rise and fall dramatically. When this occurs, the different metal layers in the tip expand and contract repeatedly. This temperature cycling leads to metal fatigue and ultimately tip collapse. The more frequently you wipe the tip, the more you stress it. It is important to clean your tip often, but not constantly. We recommend gently dabbing it into a brass mesh pad or swiping it over a genuine cellulose sponge slightly dampened with deionized water. Domestic plastic sponges should never be used. When a hot iron heats the plastic, it can release chemicals that can corrode the tip. It may also release fumes that could be harmful to your health. The use of tap water will cause mineral scale to form on the tip, resulting in a non-wetting barrier. This can have the same type of effect as an oxidized tip. The brass pad is the preferred method of cleaning the soldering iron tip. That's because the temperature will not rise and fall. The other problem with excessive tip temperatures is that the higher the tip temperature, the faster that oxidation will take place. Always use the lowest possible working temperature. 315 degrees C or about 600 degrees F is a good starting point for hand soldering applications. Another cause of tip damage is using excessive pressure during soldering. Many operators feel the need to press down harder when confronted by a difficult connection in order to transfer more heat to complete the connection. But pressing harder doesn't make the connection heat up any faster. Not only does this practice cause damage to the circuit board lands and laminate material, but the soldering iron tip itself can also become deformed. Here are some examples of tips that have been deformed from too much pressure. Notice that this typically happens with conical or pointed tips. Very fine surface mount tips are particularly susceptible. Bending the tips will eventually cause the plating to develop micro cracks or fissures. Once a fissure is created in the tip's surface, the copper core is exposed to moisture, oxygen, and tin. This mechanical damage will speed up the erosion of the copper, and the tip will no longer be usable. Cracks in the tip plating can also occur from careless handling of the soldering iron, even with large tips. Some operators heat up the tip and purposely deform the tip, thinking it will make their job easier. This too will speed up the erosion problem. Both excessive pressure and excessive temperature can be prevented by selecting or procuring the right shape tip for the job. Effective heat transfer is mostly accomplished through proper tip selection, specifically the contact area and the thermal mass. When selecting a tip, always select a tip that has the greatest contact area without overhanging the joint area. A chisel tip with a flat surface has a much greater contact area than a conical tip. It's important to always use the tip closest in size to the width of the land to be soldered, but never any wider than the land. What you want is the maximum tip-to-land contact area to heat the connection quickly. Imagine the tip-to-land contact area as a plumbing pipe in a swimming pool. A 1-inch pipe will take 15 minutes to fill a 300-gallon pool. A 15-inch pipe will only take 1 minute to fill the same pool. Using a soldering iron tip with the greatest area of contact with the land will allow the tip to transfer its available energy into the connection much faster. The thermal mass of the tip is also important for effective heat transfer. Thermal mass relates to the size of the tip and the amount of heat it can hold. For example, a tip with a weight of 1 ounce heated to 600 degrees Fahrenheit may be able to heat 7 grams of copper to 600 degrees before the heating element has to energize and restore the tip temperature. A tip with a weight of 3 ounces heated to 600 degrees Fahrenheit may be able to heat 21 grams of copper without the heat element energizing, even if the contact areas are identical. This means the soldering operation can be done faster. The thermal mass of the tip is important for connections that dissipate heat quickly. This means that the solder connection needs to be completed as quickly as possible while allowing for adequate solder wetting. Having the wrong tip size on your soldering iron can cause other problems. For example, if the tip is too small, there may be incomplete solder flow or a cold solder joint. Too small a tip will also increase the dwell time, or the time the soldering iron is in contact with a connection. Increased dwell time is due to poor heat transfer, which happens when you use a conical tip on a large surface area. Increased dwell time can lead to component, conductor, or circuit board damage. If the tip is too large, it can overhang the connection area and cause thermal damage to the circuit board substrate. These are the reasons why tip selection is such a critical issue in the hand soldering process. Another tip life factor involves feeding the solder onto the tip to force it to melt. This is different than quickly touching the solder to the iron before moving it to create a heat bridge. When the solder is continually fed onto the tip, the active fluxes cause rapid surface oxidation, which forms pinholes in the plating. The tin eats away at the copper, which causes the holes to enlarge. Once the copper begins to dissolve, the tip becomes unusable. These are examples of tips that have been damaged from feeding solder directly onto the tip. The best way to protect the tip during soldering and to create the most efficient heat transfer is to use a solder heat bridge. To do this, the tip of the iron is applied to the junction of the land and the lead to be soldered. This starts the heat flowing to the connection area. The heat bridge is formed by touching the solder to this same junction, then moving the solder wire over to the opposite side of the land. This causes the liquid solder to move toward the heat source to complete the solder joint. Our final topic for extending soldering iron tip life has to do with mechanical damage due to tools. Using pliers to remove and replace soldering iron tips will often create tooling marks on the tips, which will invalidate any warranties. When changing tips, always use gripper hot pads. Gripper hot pads won't damage the tips and will also protect your fingers from being burned. It's important, especially in the case of a tip with a 30-degree long sharp bend, that we not push the tip down against a solid object when inserting it into the handle. This could damage the end of the tip. It's even a bigger problem if the heating element is in the end of the tip. Another factor in mechanical damage is to make sure that the soldering iron support stand is the correct one for the iron. An improper stand can result in the iron dropping out of the holder if it doesn't locate correctly into the funnel. This program has presented the essential information on soldering iron tip care. We started out by discussing why tip care is important and examining the composition of a soldering iron tip. Then we took a look at how to prevent plating failures and oxidation damage. Finally, we described the problems that occur during the hand soldering process, including using the wrong tip temperature, excessive pressure, incorrect tip geometry, feeding solder onto the tip, and mechanical damage due to tools. Remember, lead-free means reduced tip life and greater operating costs. Proper maintenance of soldering iron tips will greatly increase tip life. If you find yourself burning through tips faster than your coworkers, there are specific reasons why this happens. It's kind of like a scuba diver, where they use a lot less air as they become more proficient, so they can stay down much longer. A professional knows how to preserve a soldering iron tip and takes pride in using their tools properly. By treating tips with care and respect, you'll be doing your part in not only improving the quality of your solder joints, but in saving your company money and helping to increase profitability.